Hey guys, okay, we're gonna do the video for 5-7. All right, we're gonna do the end behaviors. Okay, so we're gonna do two examples on this, and here's the first one. So this one here, this problem here, this is a parabola, and we're just going down the list like we usually do, but we got two new points, and we're gonna talk about those. So the vertex is this point right here, the point of change, and that is 4, -9. So the vertex is 4, -9. Now the range is the limits of the y-axis. So the bottom of this parabola is -9, and we're going up to infinity. So -9, we're going to put a bracket around that to infinity. The domain, it's always getting wider along the x-axis. So that's -infinity to +infinity. The x-intercepts are these points here. So that's 1 and 7. So you have x equals 1 and x equals 7. The y-intercept is right up here. That looks like y equals 7. Now the interval of increase and decrease. Now this is where we want to pay close attention because it's very similar to these. Okay, so I am leaving -infinity, and as I leave -infinity, the graph decreases until I get to the vertex and changes direction. So from -infinity to 4, this graph is decreasing. I'm going to label that -infinity to 4. Then from 4 to infinity, the graph is increasing. Okay, now starts the end behaviors. This is the new part. So end behaviors. As x approaches infinity. So what that means is as we're going along the x-axis, what does the y-axis do? As we go along the x-axis and approach infinity, what does y approach? Well, as x approaches infinity, and notice this time I'm kind of covering the entire graph from the y-axis out, right? We're covering from infinity, and then we're going up to infinity. Now, as x approaches -infinity, actually kind of did this backwards. As x approaches -infinity, the graph is approaching, the y value is approaching infinity as well. Okay, so let me recap this. And let me do it in the right order this time. As x approaches infinity, okay, so as the graph goes this way along the x-axis, along the y-axis, it continues to increase. So as I go to -infinity, or as I decrease along the x-axis, the y-axis continues to increase. So as x approaches -infinity, y approaches infinity. As x approaches infinity, the y values approach infinity. Okay, next example. Okay, so this one's talking about rate of change. The formula for rate of change you might know is the same formula for slope, which is y2 minus y1 over x2 minus x1. We're using that formula again. Now here it says the interval, what is the average rate of change for the given function over the interval of -2, 5. So -2 is right here, and then 5 is right there. I'm going to label this x1 and y1. Label that x2 and y2. And I'm just going to plug that right into this formula. Remember, this is not saying -2 and 5, it's saying the rate of change between the x value of -2 and 5. So what's the slope of the line, or how much does it change on average? Okay, So, and these are interval notation. These are both x's here. So I'm just going to plug that in. So let's see here what I got. I have 25 minus 4, then negative 2 minus 5. Now, you may be wondering why I just didn't follow this order. The order actually does not matter as long as you keep them the same. So if I used x1 here, I have to make sure I use y1 here. If I used x2 here, I would have to make sure I used y2 here. Just got to make sure they stay on top of it, like in order. Now, 25 minus 4 is 21. Then negative 2 minus 5 is negative 7. And sometimes you can simplify them, sometimes you can't. In this case, we can, and we're going to get negative 3. And that is the average rate of change. Okay, guys, I hope you guys found this video helpful.